I would just we'll get started in a minute. I will I'm trying to address an issue here with the computers. So for you guys that are connected online, this will be back in a minute. Yes, so I'm here. I apologize. We are trying to address an issue with the computers. Um, so we need to get started. We will try to fix those problems later. Um, Today's lab will be more into learning sequence of logic. We are not going to be learning a lot of new blocks today, but we are going to be learning a sequence of blocks that is very important when trying to model manufacturing systems. And the logic that we are trying to work on today is the logic for the interaction with the operators and the machines. So for instance, if you need an operator to do a setup for your machines before you can start production, we are going to show you how to build like that logic into your model. Typically, you would have an operator who will do the setup, the operator will leave, machine would do the processing, and sometimes you have, after completion of the process, you need the operator to go back to the machine to do the removal of the part and then set up the part again, the new part again to run a second product. So that's the type of process that we're going to be modeling this afternoon. Again, our focus today is to learn that logic. You'll see that when you start doing practical simulations like real time or real life simulation, that logic will show up a lot. And you will see that in your project too. So it's not just looking at the machines by themselves, but also looking at the interaction of the operators with the machines. So lab 3 is about that. Terminology, we already discussed this terminology. Again, make sure that you understand the difference between an attribute and a variable. We are using attributes of the type of priority, well, not yet, but cycle time for the arrival time. We also have used attributes for the type of product, like part types. We have used variables to illustrate the not many things so far. We have discussed the working process, but we haven't modeled that yet. So we're going to learn that in the next couple of labs, how to represent that using a variable. So for now, we stick to the attributes, arrival time, and part type. Those are the ones that we've been using so far. Please remember to save your projects or your models when you're working on a new model. In terms of the modules that we are going to be using today, we're going to continue using the Simon blocks and elements. Elements are used to represent the experimental frame, and the blocks are being used to represent the model frame. And we know how to model a resource. Typically, we have 3 delay release. Today, we're going to have a different combination of these seize delay release, seize again. So we're going to see how these blocks can help us build a logic for the interaction between the operator and the machines. Attributes, the branch block we discussed, this is like an if statement that you use to build the logic if you had to split units, entities, and so on. And we also discussed the different types of statistics last time. So the counters, tallies, the time average statistics, time persistence. We use the TAVG for the output report for the tallies. We use the DAVG for the output report for the time average statistics. And we use the NR to generate the output report for the counters. There's a description here for the difference between tally and time average statistics. Again, the tally is more like a bag in which you put observations from the system, and then at the end you do an analysis or compute some statistics based on that bag of observations. Time average statistic is statistics that is changing across time, and you're estimating the value based on the changes of that statistic across time. We also discussed how to use a set for separating the observations and computing statistics by type or by part type. In terms of new modules, today we can also compute the average number of parts in the queue. This is also a time persistence statistic. We haven't used that one yet. But for example, Palaniapani has been using that statistics to collect the average number of passengers that are waiting in queue for a checkpoint in his research. So that's the type of statistic that we are going to be collecting today. So what is the average number of people waiting in queue, number of parts in this case waiting in queue across time? Statistics among replications, so we use the output element, as I mentioned already. And this is an example of the output report. So let's go into the model for today, the example. So again, we have this setup in which we had two machines coming into some parts coming into the system. We had two type of machines, or one type of machine, two capacity two for the same identical machine. But now we're going to have a single operator who's going to set up each part on the machines and remove each part from the machines. So two machines, single operator will be moving around, doing the setup for each machine and also doing the removal for each machine. We have some additional information here for the setup and removal times are distributed according to a uniform distribution. So the setup time, it follows a uniform distribution between 2 and 4 minutes, and the removal takes between 1 and 2 minutes using a uniform distribution. So we're going to build the model, arrivals, the two machines, and the operator doing the processing. The question we want to answer is how many parts are processed in 8 hours, and what is the average number of parts in the queue, and what is the average utilization of the machines. Okay, so again, the only difference today is that we're going to have this operator doing the setup and doing the removal of each part. So, yes, sir. That's a very good question. So, so the question is, in reality, when we go to a practical problem, we are not told that we have a specific distribution for the arrivals or for the processing times. So the question is, how do we know what type of distribution these problems are following, or these processes are following? The answer to your question, for now, I'm going to give you that information, but part of the project, part of the experience of developing the project is to learn how to build these probability models. What's going to happen is you're going to go collect data, and then using that data, you're going to set up some histograms that are going to tell you, okay, the frequency of each observation, and also if you're looking at processing times, the amount of time it takes to complete each task. And then using these KS test and the chi-square test, You should have learned in probability and statistics, so we're going to touch on that again. We're going to fit the probability distribution from a list. So we're basically having a list of 10 probability distributions, and we're going to try to fit the best using these chi-s and chi-square methods. So we're going to do that in class for now. Again, very good question. For now, we are just assuming that this information is given, but I'm going to teach you how to build these probability models also for your model. And as part of the project, you're going to go and do that in real life too. We have a software package within Arena that is helpful in doing that process. So basically what we're going to do is we're going to feed the data to the software, and the software is going to perform all these chi-s, chi-squared statistic methods into the data that we are feeding, and it's going to tell us a report. This is the best probability distribution that is fitting your system. Typically, you would start with a, let me see if I can give you some. For example, you can have something like inter-arrival times. So let's say this is 5 minutes, 10 minutes, 15 minutes, 20 minutes. So this is minutes. And this is the frequency. So you will count, or this, I mean, you're going to feed this data to the software, but what the software is going to do is going to say, okay, how many times you have arrivals happening between 5 minutes? Maybe one time, maybe between 5 and 10 is 3 times, between 10 and 15 only 2 times happen, and before 15 and 20 minutes only 1 time happened. So it's going to go and look at, okay, this is the curve that best fit this histogram. Tell me which probability distribution better fit this curve. And if you remember, each probability distribution has a PDF. So for example, the exponential looks like this. The normal, standard normal looks like this, and so on. So all those curves are going to be used in understanding, or basically fitting, the best shape into the histogram, and the one that shows the best fit is the one that we're going to use to model the probability and the processing times and the arrival time. So very good question, and we're going to work with that. I think right after spring break, we're going to be building those models. Okay, so let's try to build this logic in Arena. Okay, so let me make sure that you're understanding what's going on. So what we are going to model today we have these 2 machines, machine 1 and machine 2, and there's a single operator that's going to go here, is going to set up a part, and then he's going to leave. And then if this machine is idle, he'll come here and he will set up this part too. And then once the part is completed, So if the part is completed, then he has to come back here, remove the part, and then come back here and set up the next one. And he'll be doing that based on the availability of the machines. So a single operator moving between these two machines, one becomes available, we'll set up, the other one is completing the processing, it will go pick up that part, remove that, and then go set up the machine again. So that's the logic that we are building this afternoon. He will remove and he will set up both machines. Okay. So if we have two machines and one operator, we would expect the operator to be really busy because he is going to be handling two machines by himself. So let's open Rena. Then I'm gonna try to keep the description here. Okay, so we have this. We're gonna start by adding the templates if you don't have them already. Blocks and the elements. And I'm gonna just write experimental frame. Here. And we have the model frame too. Okay, so I'm gonna start adding here the elements that I'm gonna need. So I'm gonna start with the queues, resources, and for the statistics, I need some counters because we need to count the number of parts being processed. And we also need average number of parts in queue. So we need some DAVG or D-stats. And then the outputs. Okay, so we need just a single queue. So I'm gonna add here queue. Or let's just say machine queue. Machine queue. So that's the name. And then for the resources, we just need a single resource with capacity 2. So I'm gonna call this machines. And we're gonna have 2. So they have the same processing time, so they are identical. So I'm gonna put a 2 here. 2 machines, capacity 2. Again, the reason I can do this is because both of them have the same processing time. Since they're identical machines, I can just name a single resource and put a capacity of 2. If each of these machines have different processing times, I cannot do this. I have to model different, separately. Yes. There's different ones. The utilization is what is the average utilization of the machine? Oh, yes, but that's for the operator. The operator is a separate resource. It's the person. Machines it's just the machines. So the processing time for the machine are listed here. And then we have 2 with the same processing time. Okay. And now that you mention it, we need another resource. We have an operator. Operator. Capacity 1, because there's just 1. So we have the machines and the operator. For the counters, we're going to have 1. We're going to put these parts completed. Okay. And then I'm going to work with the statistics after I build the model. Okay, so let's build the model. So first thing I'm going to need is the create block. Right? So we know we're going to be creating parts, turbo, paddles, and exponential 4.4. I don't think I saved this, so I need to save my model. I'm going to do that now. So fail, file, COS. Okay, so after the creation of the entities, I can move into my queue and I move those entities to the queue. And I have identified the name of the queue already. So this is machine queue. Okay, so now's where the logic starts. Okay, we're gonna seize. What are we gonna seize now? Yes, but in order for you to do the setup, which resources do you need? You need the operator and what else? So you have to seize both, okay? And that will be the first step. Now it's not just seizing the machine, but you need also to seize the operator in order for you to be able to do the setup. So both resources needs to be available for you to complete this task. If only the operator is available and none of the machines are available, you cannot perform a setup. But if both of them are available, you can set up the machine. So that's what we're gonna do here. You're gonna say, okay, I need to seize. Let's start with the operator. It doesn't really matter as long as you put them both and then the machines. So I'm gonna seize a machine and an operator. I'm going to delay these for how long? The setup takes uniform distribution 2 to 4. So I have to delay. This delay is going to be representing the time it takes to do the setup. So duration, you can build the expression here. You go to random distribution, find the uniform. It's going to ask you for the minimum value and the maximum value. So this is 2 and 4. So this delay if I do this, that delay is representing the time it takes for you to do the setup. So what's happening next? I got the processing. What else do you think can happen before we do the processing? What needs to happen before I do the processing? Because right now I'm keeping the operator with me.
Do you release the operator?
Yes, we have to release the operator. So you do the seize delay release, but at this point you just release the operator. Okay, so I'm gonna go here, gonna find the operator. And at this point, I have completed the setup. But the machine I'm still holding the machine because I need to process the part. So now I can go and do the delay for the processing. And this, again, we can use the expression builder, random distribution, triangular with 3.2, 4.2, and 5.2. So I'm processing the part. Now the processing time is completed. What's next? Yes. So now you have to seize the operator again. The machine is still with us. Yeah, so we just seized the operator. We haven't released the machine at any point yet, because we need the machine with us from setup to release of the part or removal of the part. So we are going to build that logic. We're going to seize the operator again. And we need to delay this by the time it takes to do the removal. So we're going to build an expression here. Uniform. This 1, 2. And then finally, we have our release of both. Yes. So we are going to release operator and the machines. I think if you change the order, you will see a difference in the numbers. It doesn't really matter as long as you release them on the right place. Okay, so so I'm putting operator and then the machine. And then do the connections. And then at this point, we are going to count the number of parts completed. So it is the counter I did is parts completed. You okay? Yes. And then we're gonna dispose. Okay, so how many parts are completed in 8 hours? We have the counter. The other statistic is what is the average number of parts in the queue. Okay, so I'm gonna show you how to get that. Number of people or number of parts in queue is again a statistics that is changing across time. So we're gonna use the dstat. And we are going to use a software-defined variable to collect that information. The name of the software-defined variable is NQ. And then we're going to put inside NQ the name of the queue, which is machine queue in my case. It's for the queue, yes. So this is going to compute on average how many parts are waiting in the queue at any time. And then we also have to do the utilization. So I'm going to put here, this is something that we did in our previous lab. So it's NR, the name of the resource, in this case, machines. But since we are naming our resource machines, we know that there's more than one, right? In our case, we have two. If we just do NR machines, what this is going to do is going to add the utilization of both machines. So if we want to get the utilization of a single machine, we have to divide this by 2. So this is NR machines divided by 2. And then it's not asked here, but I also want to see the utilization of the operator. So I'm going to do NR operator. Operator is just 1. So I'm not dividing this by 2. I want to look at that, even though it's not being asked by the exercise. I want to see the utilization of the operator. Okay. Yeah. So, so if I want to get, let's say we're going to run this for multiple replications. Again, we need to get the summary across replications for our statistics. So I'm going to do that in the outputs. So first of all, if you remember from our previous discussion, in order for us to get the output for these stats, we had to give these names. So the name, this is number in queue. So I'm going to use this name to define my output. Okay, so I'm going to go here, I'm going to copy that, I'm going to put here at Simon expression. This is the dstat, so this is DAVG, and the name that I use for that dstat, the name is number in queue. And then I can set up the name for the report as the average number in queue. So in the outputs, every time you're defining a dstat, you have to remember that you have to go back to dstat and add a name to the statistic that you're computing. And then you're going to use that name to generate the item in the output report. The name that is showing up in this window is what you're going to see in the actual report. So you're going to see average number in queue. So I want to do that for also the utilization. So this is machine utilization. So I'm going to copy all this. And then I'm gonna go to the output and add a DAVG here in my Simon expression, DAVG, and then paste that name, machine utilization, and this is AVG machine utilization. And let's do it for the operator too. Okay, so let's define the operator too. This is operator utilization. I'm sorry, I changed my style. So this is utilization. Then I copy this. I go here. The AVG operator utilization is AVG operator utilization. And then we have the counters. So you want to create the so we're going to use the NC. And the name of the counter is parts completed. And this is AVG parts completed. Excuse me? Yes, so we can do 10 for 8 hours. So check your model, see if you have any errors. Then you can go to the setup. So remember, for the setup, we're gonna do 10 for 8 hours. And the base time units is minutes. And then for the reports, we're gonna choose the Simon. And for project parameters, we're gonna uncheck all this. We want only the report to contain what we coded. So let's see if this works. I go all the way down. I get this, the operator utilization is very high, the 93%. So it's not idle a lot. Minimum is 88%, almost 90%, maximum is 96. Machine utilization, same thing, machines are being kept busy most of the time, 96%. Average parts completed, 98. And average number in queue, about 7, with a maximum of 11. And so that right there tells you on average how many parts are waiting in queue. Yes. Okay. Good. So looks like everybody is understanding what we are trying to do. So we have time. Want to see if we can try to do some animation of some of the things that we are collecting. So there's, if you go to the animation tab here, you see that there are some options. One is for the status, things like the clock, date, if you want to keep track of a variable, some charts. So let's do the clock. If you click the clock, you have an option to choose a digital clock or an analog clock. You also can choose between 24 and 12 hours. So for example, if I choose 12, you can change the color if you want. If you want to use a red, then if you click OK, you can place that. Oh, where is it? You can place that clock here. No? Ah, the results. Yes. So if you go to animate, the animate tab, the first option to the left is clock. So if you click there, you'll see this. You can choose between analog or digital display, right? Or between 12 and 24 hours. You can also change the color. But what this is going to do, animate. If I make this really slow, it's going to show you the time of the day as you run the simulation. Oh yes, because when you, let me show you. You delete this, you go to animate, you click clock, you click OK, you have to expand it depending on how you want it to look. Date, same thing. You can show the date. Scoreboard. We don't have variables yet, but we can create a plot. So let's choose the plot. Excuse me? This is an animation has multiple purposes. For example, if you are going to be presenting your model to someone that is not familiar with Arena, it's better for you just to show the animation of the model. They can see what's going on. So for presentation purposes, animation is good. Also, it helps in the validation process. Like if you want to know whether or not your system is doing what it's supposed to do, you can see the flow of the entities visually, see if they're following the process. So from my experience, practical experience, if you go to your boss and you try to present a simulation with an animation, you're not getting much from them. They're not going to understand what this thing is doing. But if you go with an animation and you show them, okay, this is what's going on, this is how the plots are changing, you'll see that they will be amazed. Yeah, and it's gonna be like, whoa, yeah. And that's my experience. Several times that I presented this in different places, the animation makes a difference. Things like, yeah. So for you to explain this to a non-expert, animation, yeah, is the way to go. But from a modular perspective, it is also helpful in terms of understanding what's going on with your system. So let's see how far we can go and show you some things. We're gonna do this throughout the semester. So for example, if I want to create a chart, see if I can understand the new module here. We have an axis, left value, right axis. We have to choose the data series that we want to follow. So let's say we want to know when I keep track of the counter, maybe you can do that. So I can change the name here to parts completed. The expression. So I want to keep track of the parts completed. So I went to the expression. I built an expression, went here, selected the counters, the value, and it asks you which one you want to follow, which counter. We only have one, so I selected that one. And then I can do the same thing. You can edit the colors and everything. For now, we just want to see how that looks. So you see, as you move forward, this is going really fast. So let's see if I can slow this down. So I go run setup, run speed. So if you go to setup, you can change the animation speed. Run speed at the top. You go to run setup, run speed. If you add more zeros, I'm gonna add 2 more zeros after decimal place. Enter a number between, that doesn't like it. It's just at 1 0. This is going a little bit slower now. So it's showing what we are supposed to see, right? We see this number goes up all the time because we are adding more units. It gets to 80 something, and then it starts again is 0 because we have another replication. 20, 40s, 60s, and then 80s, and then go back to 0. Yeah. Let's see. What else you can do? Let's see if I can animate our queue. We have the machine queue. See what's going to happen if I do this. I don't know if the entities are going to show up. Let's see. No. Because I haven't animated the entities yet. I apologize for that. Okay, so we have entity picture placement. So the entities are not showing up. Okay, so yeah, we can do the resources. The entities a little bit more challenging, but I'm going to show you how to do that with the different. Oh, here we go. Entity. Okay, so we're gonna. So if I go here and run this, they're not showing up. Yeah, so you see, for the arrivals, I still need to check how those are built, but typically what you'll see is that you get those arrivals getting into the queue. We can model the machines. Like, for example, if we go here to resource, we can select the identifier, machines, and then here it's a simple representation where white represents idle, green represents BC. These lines represent inactive, and then red represent failure. So you select the machines, you can come here, put that box that is representing the machines into your animation, and it will help you keep track of the status of your machines. Like, for example, in our case, we expect that to be green most of the time because we notice that the utilization is very high. So once it gets green, it's busy for the entire replication. And then once we switch to the next replication, it needs to be busy. And that's the way it's supposed to be. We can do the same thing for the operators. You go here to, let me show you. You go to resource here in the pictures. You select the resource that you want to model. And then you have 4 states for the resource. You have the idle, the BC, the inactive, and the failure, I think. So you can use this default library. We have more libraries. Let's see if I can find those. Yes, so if you click open here, you have more libraries inside the arena, like for equipment, for instance. And it would show you a different group of pictures here for equipment. You used to have more pictures. I need to find those. So we have the general, the people, and the vehicles. So for example, idle could be this picture, BC could be this picture. And then I can click, but this is an operator. Let me change this to machine. Right, so now when I run my model, you'll see that this is going to change. Yeah. So it's going to stay busy until it goes back to idle, but now it's just operating, you see? And we can choose, there's multiple libraries. And obviously what I'm showing you now is very limited, but there are libraries that we can use to build these animations. I think Arena is a little bit limited in terms of generating good animations. There are other software packages that are more easy to build the animations, like Simio, for example. But that's it. This is the assignment. The assignment is posted for next week. So if you want to explore the animation option, it's up to you, not required. But again, it's useful when you if you get familiar with the animation process, which we're gonna continue doing this semester, then at the end, you can have a good representation of your system, and that's very helpful for the validation and also for presentation purposes. Any questions? Good. So if not, then I'll stop now, and I will see you on Wednesday.
Thank you, Dr. Bruce.
Thank you.
Thank you, Professor. So we don't have homework this week, right?
We have the lab to be open. If I'm not,
Okay, only lab 3, no homework 2,
Yes.
right?
yeah,
Okay.
just, yes.
Got it. Thank you. Have a good day.
All right.